It is now time to welcome the PICO delegation. So, Zhipeng, Jimmy, Jane, and Praveen will guide us through the process of how to write an OpenXR application using the OpenXR SDK. Welcome.
Hello all, my name is Praveen. I'm leading the open standardization effort at Bytedance for the PICO VR headset. We have some demos of our device on the lobby. Please do check it out. So we are using OpenXR as a part of our open standard effort. So along with me today, we have Jimmy Alamparambil and Liu Zhipeng and our product manager, Jane Tian. Zhipeng and Jimmy would be going into more details, technical details on how to incorporate OpenXR. I want to explain the rationale of why we are doing OpenXR in our runtime. So why for all? Okay. The first reason is we want to future-proof the development of applications so that you can run across various future XR hardware that do come up. This also reduces vendor lock-in for developers and makes software easy to be adopted to future devices. It also helps cost saving both for us and for app developers because you'll have a code base that you can reuse. The next one is quite big. It's the market reach as well. With OpenXR support, developers are able to reach wider audience across different ecosystems and devices as well. So this expands their market potential. It has become almost becoming a de facto standard as well in the industry. This in turn makes devices that support OpenXR something attractive to app developers. Think of it as the chicken and egg problem. At least we are solving something here. The next is innovation and development agility. What I mean by here is when you focus on one standard, developers can innovate faster and not spend too much time interfacing with different platform complexities. And also OpenXR is extensible. So even if there's something that is not, some bleeding edge feature you want to use that's not available, you still have the ability to specify some extensions that you want to use. Due to the standardization, it helps PICO also to onboard new app developers or company that wants to use our platform. That's a huge win for us. Next is the partnerships and collaboration aspects. I think Ron mentioned earlier today that we've been spending 4 days, collaborating with all the companies that are here. That is very important to us because it ensures that our platform is also aligned with the industry trends. And by aligning with OpenXR, we are also able to establish partnerships. We are able to collaborate and figure things out. And one of the important things from a business perspective is our long-term risk. We put quite a bit of investment in this, and we want to reduce fragmentation, and OpenXR is one of the ways to do it. Also, we are trying to achieve some sort of vendor neutrality so that it kind of helps us being flexible. Finally, the whole alignment with open standards movement, there's quite a few industry involvement in this, where they want to drive innovation and interoperability. And by supporting OpenXR, our organization at least aligns itself with broader trends towards openness, making our product more attractive to partners and clients. With this, I would hand this over to Liu Zhipeng, who's going to go into a lot of details. Thank you.
Okay, thank you, Praveen. Hello, everyone. How are you? Great. Okay. Okay, my name is Zhipeng Liu, and from PICO Bytedance, I'm the tech lead of our XR runtime team. Since Praveen has given you a lot of good reason to build a cross-platform XR experience with OpenXR, I will show you how to do this. My topic will be a little bit technical, and let me go straight to the point. Okay. Firstly, we need to set up the environment. We need the hardware and software. For the hardware part, we need an XR headset, and like the PICO for Ultra in my example. And we also need a PC or laptop and the USB cable. For the software part, I think we need to download and install the Android Studio. And we also make sure the JDK version meets the requirements. And we also need the OpenXR SDK, of course, and you can download it from the GitHub. And there are also OpenXR tutorial project with the OpenXR SDK inside. This one, I will take it for the example in my sharing. Okay, firstly, I think we need to set up the Android manifest. Actually, if you use PICO for Ultra, you do not need to do any modification to this file. You just need to use the standard launcher intent filter. But if you want to use some capability that may need users' permission, you need to add the permission declaration. And it is also recommended that you add the metadata for system check, version check, because it can avoid you from the compatibility problems. Okay, here is the overview of the framework of the main function in the demo. On the left side, we can see it just create the instance and get the system ID, which could be used in the subsequent function calls. And then it set up the interactions, create the swap chains, create the session, and as well as some resources for rendering. And on the right part, we can see it will be done in each frame. The pull system event is an Android-specific function to handle the system platform event. And the pull event is to handle the OpenXR event. Okay, we also need to do some rendering work in the render frame function. And finally, we need to call the destroy functions to release the resources when the app stops. Okay, let's dive into a little bit more about the framework. The XR instance is the first fundamental object that you need to create because you can use it to communicate with the runtime. And the second object you need to get is the system ID. System ID can represent a collection of related devices. It could be a VR headset plus a pair of controllers, or it could also be a mobile device with a video see-through for AR. Okay, the next primary object we need to create is the XR session, which encapsulates the state of the application from the perspective of OpenXR. And it has several lifecycle states just showed in this diagram. After its creation, it starts from the idle state. And it is up to the runtime to provide any updates to the state. And it is up to the application to query the updates and react to them. Okay, OpenXR uses a event-based system to notify the changes inside the system. The developer needs to use the XR pull event function on each frame to pull the event. And sometimes there may be multiple events in a single frame, and the application needs to handle all of them. Okay, after we set up the OpenXR framework, here comes the graphics setup. It is a very large topic that I will not cover all of them. I will only cover some key points here. The most important object you need to create is the swap chain. It is a series of images to present the rendered graphics. Usually there are 2 or 3 images inside the swap chain. And when you do your rendering work, there are 3 main functions that you need to call. They are XR wait frame, begin frame, and the end frame. So these three functions should be called and can only be called in such sequence. Okay. After we set up the graphics, we need to set up the interactions. The interaction also is a very big topic. That's how we will not cover the whole picture here. Here are some key concepts here. The first one is the action. It is a semantic object not necessarily associated with a specific hardware. For example, you can define a selection action rather than define a section action for pressing button A. The action set is just a group of related actions. And the interaction profile is a collection of interactions that's supported for the runtime on the device. And it is defined using the textual path, just like the example. And the last one is the bindings. It is the correspondence between the actions and the interaction profile. So here are the procedures to set up the system. Firstly, we need to create the action set and as well as some actions within this action set. And then we will create some correspondence using this suggest the interaction profile binding function. And next, if you want to track the controller's pose, you need to create action space, and then you use the XR location space to track its location. And finally, you need to attach the action set to the target XR session before it starts. And when the app is running, you can pull the actions by using the XR sync actions and get the action states. Okay, as we all know that the OpenXR is an extensible API, so you can use many kinds of extensions like the KHR, EXT, or many vendor extensions. If you want to use other extensions, you just need to check the extension support for the specific runtime, and then you enable the extension you want when you create the XR instance. And all the data structures and the functions are defined in the header file of the OpenXR, and you can just get the function pointers by calling the get instance proc address function. Okay, let's see what Bytedance runtime support now. It supports the standard OpenXR Android loader, which means you do not need any private loader. You just use the official one. And there are also more than 40 extensions supported for our runtime. Okay, after you finish all those about steps, you build the APK and install it to the PICO for Ultra, you will see some keyboards just in front of you like this picture. And my sharing is in a very high level. So here are some useful resources that you can take for reference. Okay, that's all about my sharing. And next I will invite Jimmy to share something from the engine side. Thank you very much.
Hello, Seattle. How y'all doing? A lot of XR people here. It's very exciting to see all of you out here, a diverse group. Excited about presenting this stuff here. So Zhipeng told you how to create cross-platform XR apps using OpenXR. And I want to make it simpler for you. My name is Jimmy Alamparambil. I work at the Developer Technology Group within PICO, and our job is to make things simpler for developers. So hopefully we can make things simpler. How do we do this? We use the engine OpenXR plugins. So we basically let the engines do all the complicated work, and we just take advantage of that and help the developers take advantage of that as well. So starting with Unreal. So Unreal has an OpenXR plugin, and we provide OpenXR SDK for Unreal which provides our own plugin that works together with theirs. So you can actually just take a device-specific OpenXR plugin, and other devices will have their own versions of this. And you can basically enable it in Unreal by adding it to the plugins setup for VR. This will enable a lot of the features that we provide, and you can configure settings of those specific features. And once you have done that for specific features for each of the devices, you can then go in and start using it. And to start using it, it's as simple as using some of the higher level abstractions that are provided within Unreal. For example, you have blueprints, and you could also use C++ if you wanted to provide, like they also provide the APIs for that through C++. But with blueprints, you can just drag and drop some things into a blueprint. And you can have, for example, here, we just implemented pass-through using blueprints. So it's as easy as that. Moving on to Unity. Unity also has an OpenXR plugin, and we also provide our own plugin that provides extra features through our plugin. So the way you enable that is download our Unity OpenXR plugin, go into XR plugin management, go and check the box, and you're all set up. And then you also have settings for the OpenXR portion where you can enable some of the features that we provide. With Unity, again, you have higher level abstractions that you can use that makes your life simpler. There's XR Interaction Toolkit, which provides like high level component-based interaction system. So you don't need to code, you just basically pull these components together and it'll basically create your interaction system for you. So no coding involved. This toolkit also abstracts a lot of the cross-platform XR inputs like controllers, touch, hands, etc. And this means it also works for mobile. It has interaction managers, interactors, and interactables. This allows you to set up all the interactions within your system by saying, hey, you can make your finger a poke thing, and you can make a game object in the scene pokeable. So basically, you could do all that stuff just using components that already exist. Or you could make even custom components to do all these different kinds of interactions. It already includes basic interactions like hover, select, grab. It gives you visual feedback for your interactions and basic canvas UI. So you can actually get up and running really fast by using these higher level abstractions. Another higher level abstraction that Unity provides is AR Foundation. This helps with your MR implementations. You can build and ship through AR Foundations, and you can target all these different platforms. In fact, AR Foundation started off on mobile. So a lot of you probably, I don't know how many mobile developers are here? By show of hands? There's a few, okay. So if you already use AR Foundation in your XR applications, you can easily move it over because you don't need to make any code changes. If you can easily move it over to headsets that support AR Foundation. Granted, there are a few, but it's going to start growing once Unity starts supporting some of the things that we're working on, which are like the spatial entities, et cetera, that OpenXR is going to provide. PICO supports spatial anchors, body tracking, and meshing through AR Foundation. Coming soon, not yet in there. But so to show an example of how AR Foundation would work cross-platform, we have set up this, taken an AR Foundation sample from mobile and transferred it over to headset. And all we had to do was very simple things. In this case, we're using the body tracker that PICO has, which is a piece of hardware that you put on your ankles, and that'll track your body pretty accurately. And we reuse the AR Foundation sample that uses AR Kit's body tracking. And all we had to change was a bone controller, and we were able to access all this functionality with very little code changes. In fact, no code changes, but just changing a component on this example. We also have other samples converted, which include meshing and anchors. And we basically use the same method to do that. And it used in fact, almost no code changes and just a few config changes to make that work. And I would like to invite Jane here to talk more about some of the future stuff that we have.
Thank you, Jimmy. So I'm Jane. I'm the product manager from PICO Bytedance. I'm here to bring you some exciting news. And I'm going to talk about the OpenXR update to support the XR headsets. We just launched our new PICO 4 Ultra earlier this month. So we are excited to also announce that we will be providing full support for OpenXR 1.1.1. Thank you. And along with that, we will provide you with more mixed reality extensions. So you can expect to experience a better optimized experience with our latest device. And all thanks to OpenXR, thanks to Cornos on all the efforts on optimizing the cross-vendor app experience. Thank you all. And lastly, we are really excited that having so many developers on our platform. And if anybody want to get connection with us, send us feedback, feel free to join our Discord and Twitter group to give us more feedback. All right. Thank you so much.
Thank you very much. Thanks to the old Bytedance team. We unfortunately don't have any time for questions, but I invite everyone in here after the presentations to go see you guys in the other room. Thank you so much.